Good evening, everyone. Good morning. Thank you for watching. So if you're following along in my playlist, and you can find this on my channel, the PIC10F200, you will see that I have already included a video where I blink an LED in assembly. But truth be told, I borrowed a sample code off of the popular Gulagum YouTube channel, and what he does is he uses like a shadow register, and I'm not familiar with that, not yet anyway. So I knew I had to create a blink code for myself, and I've done that. Alright, so here's the code I created. I'm going to go through it line by line. In a moment I will. I spent maybe 2 hours, maybe more than that, trying to get this to work, and I was having trouble. And I have a textbook which has some sample code. The textbook is specific to the 18F family of chips, and there's various ways of creating delays, and the text liked to use equates, and it would put them typically before the org directive. So I think that was maybe tripping me up, because for the last 2 hours it's been technical problems that I've been having with MPLab. Another thing that is important is to make sure that over on the left in the projects drop down folder that you're actually working with the ASM file. That's a different source of confusion that I had. I can vouch that this code works. I got it to work. What I will experiment with after I've gone through everything is putting in the equates and seeing if I can get that to work. And what the textbook was doing is it was putting some equates up here for the sake of creating counters, and then it would create certain files that would hold the counter values, and then it would decrement them using the DECF and BNZ instruction. Now I will read verbatim from my textbook on P78 on the subject of using the BNZ instruction. It says the BNZ, or Americans might say BNZ, branch if not zero instruction, is supported by the PIC18 family and not earlier families. Well, I'm using a PIC10F200 chip, so I can't use the BNZ or BNZ instruction, which is fine. I've just replaced it with the DECFSZ instruction, which works fine. I'll have to double check, but when I go to the PIC10F200 datasheet, I am expecting that I will not see BNZ there. Of course, that's like a conditional branch based upon a status register, But that's getting off into a different tangent. I used DECFSZ and the GOTO instruction. So folks, if you're watching, forgive me because I'm not working through this in the order that is best for learning, for your sake. I suppose if I did that, I should just read the code line by line and explain it slowly. That would be a better video. Well, I'm getting to that. I do appreciate you watching, but this is a memorandum to myself, so I'm just including information that tripped me up through the process of creating a Blink sketch. So I'd like to point out that in the 10F200 data sheet, the RAM, the register or the file registry, on page 13 there's the register file map, and the PIC18 series is different. It sticks all the special function registers at the end of the file register, while all the family series of PIC chips that came before the 18F put all the special function registers at the top of the file register. So you'll see this is the 10F200 that the first 8 or 9 bytes are special function registers within the register file map. So if you're going to create equates or counters, this just makes sense to me. I'm just thinking this through myself. Hope I'm not wrong, but I think you want to start using the general purpose registers. So if you're going to create counters and things like that for decrementing to create delays in assembly language, you want to address those to the general purpose registers, which come after the SFRs. And with that said, 10H or 10H onward is the beginning of GPRs. So this isn't 10, of course. This is going to be 16 in decimal. So 10H is 16 in decimal. Just show you on the screen, here's 16 in decimal. It's 10, or excuse me, it's 10 in hex. And as I can judge, the file addresses are listed in hex. So 10H, which is 16 in decimal, is the first available GPR. Okay, I'll go through this Blink program quickly. So I set the tri-state register, and I set GP0 as an output, and the rest of the 3 pins as input, and then these are unimplemented, so it doesn't matter what you write to them. I'm only using the 1 pin in this program anyway. So I set GP0 as an output. So what it's going to do, it's going to clear GP0, then delay, then set GP0, and then delay. Here's the delay routine here. I'll go through it. So here it clears GP0, then it calls the delay. Then it starts off by moving a literal value into the working register, that being 255 in decimal, or FF in hex, which is all ones. If you have a byte, 8 bits of numbers, you have a whole byte, those are all written as ones. So that's the largest number you can put into 1 byte in a file register. So I take all ones, I put it into the working register, and then I take the working register and I put it into a file. maybe I could do something like that to specify that it's in a file, but the default, of course, is the file register, not the working register. Again, working register would be 0, the file would be 1. So anyway, I take all ones, I put it in file, more specifically 10 in hex, and then I also load up the working register. I guess that's a little unnecessary to write it again, considering I think it's already loaded up with that value, but no matter. Then I take all ones and I put it in file register location 11 hex. So now both of these files, file 10 and 11, are loaded up with all ones, ready to go, ready to be decremented. And then at here there's 2 NOPs, no operation, just to extend the number of cycles, and then DECFSZ, file location 11. And it's important to realize what's going on here. So file location 10 is loaded up, then 11 is loaded up. The way this code is going to iterate through, it won't be returning to the top of delay again. So this is actually the outer loop, if I have that correct, and this one is the inner loop. So this file 10 won't get loaded up again, but this file 11 will get sent back to here, get sent back to again, and will be continually reloaded. That's important. Notice that it goes in ascension 10 and then 11, and then it goes 11 and 10. My point is that that's going to help create an outer and an inner loop, and it's important to pay attention to how these files are specified when they're loaded up and then decremented. So anyway, this file 11 is decremented, and if it's not 0, decrement file skip if 0. If it still has a value in it, it's going to go back to here, and it'll keep decrementing from FF down to 0, 0. And then when it goes down to 0, it will skip the next line, and it'll decrement the outer loop once, and it won't skip the next line. It won't skip the next line. It'll go to again, and it will reload the inner loop, and then it will no operation, and it'll begin decrementing and cycling through from 255 decimal down to 0, and then it'll decrement that outer loop each time. When the outer loop has been decremented down to 0, it'll skip if 0, so it'll skip this next line if the outer loop is 0. So it'll break out of going back to the again. It won't go there again. It'll just go to return to wherever it was called from. Now, I didn't even talk about that yet, but most likely it was either called from here or here. So what's going to happen is, in this loop, it'll clear GP0, sending it low. Then it'll call the whole delay routine. Then it'll return back up, and then it will set GP0, at which point it will call the delay routine. It'll return, and when it returns here or here, it still needs to be told to go through the loop of clearing and setting GP0. I actually forgot this and couldn't understand why my code wasn't working. It's because I didn't include a GOTO loop to make it continue iterating through, clearing and setting GP0. So maybe it's obvious to you, but I guess I forgot it. So put a note there. So I made this video way more lengthy than it has to be. I wanted it to be quick. The only reason I recreated this today is because I need a delay routine and I didn't have one that I knew that worked properly. So now that I have this working okay, I can take this delay routine, subroutine, and I can use it in another program code idea that I want to try, which is really what I want to get at. Okay, after this, I don't know if I'll do it on camera, but I'm going to try and put some equates in here and substitute them for these file addresses which I've used. So I'm going to create some equates which I can load up as counters. And hopefully I'll just get a little clip showing the PIC10F200 on my little development board I created, and I will show you that it's blinking. Okay, great. I played around with it off camera and I set some equates up here as counters, and then I loaded them up down here just so I wouldn't have to specify the file address in the code, and I like the way this looks better. And I said it before, but I'll say it again. So here's the outer loop, which gets loaded up once, and when it iterates through the delay subroutine, realize that it doesn't have any go-tos back to the delay. It only has a go-to back to this R2, which is the inner loop, if I have that correct. So realize that it goes R1, R2, loads the outer loop once, and I guess 255 times it'll load the inner loop. But my point of emphasis is to realize it kind of goes R1, R2, decrement R2, then decrement R1. Or to belabor the point, load up the outer loop, load up the inner loop with a label of again, then decrement the inner loop, and then the outer loop, sending it back to load up the inner loop once again, and sending it back 255 times. Why? Because that is what the outer loop being sent back to the again is telling it to do.